Celestial rings and colors, exploring Coronae, Glories, and cloud iridescence. Welcome to the realm of celestial rings, where solar and lunar coronae create enchanting displays in the sky. Coronae are captivating atmospheric phenomena that occur when thin clouds partially veil the sun or moon. These ethereal displays of light and color can be observed when the conditions are just right. It is essential to differentiate coronae from halos to avoid confusion. While coronae may appear similar to the 22 degrees halo, they are considerably smaller in size. Coronae are bright disks of light touching the sun or moon, while halos have a dark region between the luminary and the halo ring. Coronae are formed through the diffraction of sunlight or moonlight as it passes through tiny water droplets or small ice crystals in a cloud. Diffraction is the bending of waves around the corners of an obstacle or through an aperture into the region of geometrical shadow of the obstacle or aperture. The diffracting object or aperture effectively becomes a secondary source of the propagating wave. Imagine ocean waves bending around a cove or spreading out as they pass through an opening. This is similar to how light waves bend around droplets. When light encounters these minuscule droplets, it bends and interferes, creating a stunning disk of bright light, known as the aureole, surrounded by pastel-colored rings. Each point on an incident wavefront acts as a source of new wavelets. These wavelets can interfere constructively or destructively. Constructive interference creates new wave trains, like the one for light that is transmitted straight through the cloud to the observer. There are many angles where the wavelet fronts constructively interfere, producing additional trains of wave fronts that leave the cloud at different angles. Because this angle of light leaving the cloud is the same as the angle observed by the observer, bright light from constructive interference is seen at various angles, forming rings of different radii called fringes. For any one color, there are faint rings of light separated by darker regions. The different colors of the spectrum have different fringe radii, causing the fringes of one color, like blue-green, to appear in the dark spaces between fringes of another color, such as red. Fringes further from the sun or moon are less bright. The smaller the water droplets, the larger the corona appears. Newly formed clouds with uniformly sized droplets produce the most vivid coronae. Wave clouds, or standing lenticular clouds, have extremely uniform drop sizes, causing the diffraction from all droplets to reinforce each other and produce bright colorful rings. Most other clouds have a wide range of drop sizes, smearing colors together to form a whitish aureole touching the sun or moon. To witness a corona, look for thin clouds partially obstructing the sun or moon. For a solar corona, find a way to obscure the sun to avoid looking at it directly. For lunar coronae, keep just an eye out when the moon is near its full phase and the sky is dark. Even pollen in the air can create coronae, especially during blooming seasons. These pollen coronae often appear elliptical with brighter spots and are visible during sunrise or sunset. The same phenomenon can be seen around street or car lights in fog. Droplets near the edges of clouds, especially wave clouds, can be very small as they form or evaporate, causing fringes with large angular radii. This makes the edges of clouds near the sun or moon often colorful due to diffraction, a phenomenon called iridescence, or irisation. The cloud must be optically thin so that most rays encounter only a single droplet. Consequently, iridescence is mostly seen at cloud edges or in semi-transparent clouds, with newly forming clouds producing the brightest and most colorful displays. When looking down from above a cloud, diffraction patterns are sometimes seen around the shadow of the observer. This is called glory, showcasing a beautiful interplay of diffraction and reflection from the cloud droplets. Like a rainbow, outdoor glories are centered on the anti-solar or anti-lunar point, but the angular size of the inner and brightest ring is much smaller than that of a rainbow, about 5 degrees to 20 degrees, depending on the size of the droplets. When viewed from an aircraft flying above the clouds, the glory is a circle of light centered on the shadow of the airplane. Look up and behold the wonders of solar and lunar coronae, along with the mesmerizing glories and cloud iridescence. These phenomena offer a glimpse into the enchanting world of atmospheric optics, reminding us of the intricate beauty and complexity of our natural surroundings.